Hi, and welcome back to my channel. This week's problem is about trying to find the shaded yellow area inside of this rectangle. Now, we have got an isosceles triangle with an area of 4 at the bottom. Just above that, we've got another isosceles triangle with an area of 1. And above that, we've got a triangle with an area of 2. And then that area of the left-hand side of the rectangle, as you can see, that shape, it's not a regular shape. It's not a shape I really even know the name of. It's got 1, 2, 3, 4, 5 sides. I suppose it's a pentagon, but it's got an area of 6. Now, can you find the area of the yellow shaded region inside of this rectangle? If you want to have a go at this problem yourself, pause the video now. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, so the first thing that I want to do is make that diagram a little bit smaller and make a little bit bigger and make me a little bit smaller. And then I am going to label this side, the top side of that triangle with an area of 1x. And I'm going to introduce these two lines really so I can tell you the height of that triangle with an area of 1. And I'm going to call that y for now. And then from there, what I'm going to do is I'm going to get this equation, a half xy is equal to 1. And that's because the area of a triangle is half the base times the perpendicular height. Now, from there, what I'm going to do is I'm going to look at the scale factor between these two areas. Now, these triangles have to be similar because at the top point of the bottom triangle and the bottom point of the triangle with an area of 1, those angles are vertically opposite. Okay, so these angles here are vertically opposite, so they must be equal. And then because these two sides are parallel, we have got alternate angles here which must be equal to each other. So we've got similar triangles, and so we can get an area scale factor of 4. Now, we can then get the length scale factor by square rooting that. And so the length scale factor is root 4, which is 2. Obviously, we're not going to have the negative version because we're dealing in area. And also, scale factor of negative doesn't really make a lot of sense, especially with the diagram. Right, so from there, what I'm going to do is if I know that the width of the triangle with area of 1 is x, then the width of the triangle with area of 4 times that by 2 is going to be 2x, okay? Timesing by 2 because that's the length scale factor. Now, I know that the area of that triangle is 4, and I had this equation at the top left here for a triangle with an area of 1. So if I times both sides of that equation by 4, I'm going to get an equation for the area of a triangle with 4, or a triangle with an area of 4. Now, from there, what I can do is I can work out the height of my bottom triangle, and it's going to be 2y, because 2x times 2y is 4xy, but it's a triangle, so you've got to half it, so 2xy is going to be equal to 4. Now, from there, I then want to consider this top triangle with an area of 2. And I want to look at my original equation here and think, how can I get the right-hand side to be 2? Well, if I times both sides of that equation by 2, I get xy is equal to 2. Okay, now from there, using the similar logic to what I've just said, I can work out the height of that triangle with an area of 2. And it's going to be 2y, because x times 2y is 2xy, but again, you've got to half it because it's a triangle, so you get xy is equal to 2. Now, from there, what I'm going to do is I am going to make this a little bit bigger, and I'm going to put myself over on the right-hand side, and I am going to start to label some of these dashed lines with lengths. Now, because we've got isosceles triangles, the apex of this triangle with an area of 4 has to be in the center. And so what that means is that the bottom dashed line, either side of that apex, is going to have to be x, and then the bits above it, because we're doing 2x divided by 2, the bits above it, I jumped ahead, are 0.5x, because you're doing 2x at the bottom, that's the full width, take away x is 1x, and then you're splitting it in half, okay? And so, at the moment, those dashed lines have made 2 triangles at the bottom that we don't know the areas of, but we can work them out. And they've made 2 trapeziums in the middle. And then we've got 2 trapeziums above them. But I need to label the top sides of my rectangle here. And I'm going to need to introduce another letter. So I'm going to call it Z. And I'm going to call the other side, but I'm going to have to call the other side 2x minus z because the whole width of the rectangle is 2x. Now, I just mentioned that we've got different shapes here made by these dashed lines. And so what we're going to start doing is working out the area of those in terms of x, y, and z. So here I've put the areas inside, and I'm putting these in black so they stand out a little bit more than the red, and you can differentiate between them. And the area of those triangles, as you can see, is going to be xy, because we've got x times 2y, and then you half it. So it's going to be xy for both of those, and they're the same. And then above those, we've got trapezia, which the equation for that is a half of the sum of the two parallel sides times the height between them. And so we've got 0.5, a half, times by 0.5x plus x times by y, because that's the distance between. Now, the top left trapezia is going to be 0.5, so a half again, times by the parallel sides added together, so 0.5x plus z, times by the height between them, which is 2y. And on the right-hand side, exactly the same thing, apart from the two parallel sides are, well, one of them is slightly different. 0.5x add 2x minus z. Now, what we can then do is we can start to simplify some of these things and work them out. So the middle trapezia simplified to 0.5 times 1.5x times y, which gives us 0.75xy. Now I can simplify the top right trapezia inside the brackets, because I've got 0.5x add 2x, so that's going to be 2.5x. And then what I can do here is I've got 0.5 times on the left and 2y on the right. I can cancel out the 0.5 with the 2 just to make things a little bit simpler for both of those trapezia equations, or expressions, not equations, expressions. Equations if I wrote area equals. And now I just need to multiply through by y, and we get this. And at this point, you might be thinking, okay, well, I've just got a load of letters here, and I've got x, y, and z. I've got 3 letters, and I've only got one equation because I've only got the 1/6 there. But we have got the equations from earlier where we use the other triangles, and we have got xy is equal to 2. And so if we substitute that in, what we get is all of this. We've changed all the xy's for 2. Now I'm going to simplify the middle trapezia. So 0.75 times 2 is 1.5, and substitute it and simplify again at the top. So we get 1 plus zy and 5 minus zy. Now we're pretty much here at this point, because on the left-hand side, I can add up all of those 3 things. So 2 plus 1.5 plus 1 plus zy equals 6, because that's the area. And simplify to 4.5 plus zy equals 6. I can take away the 4.5 from both sides, and I get zy is 1.5. And at this point, I've pretty much done it, because I'm going to substitute in the 1.5 to both those two top left and right trapezia. And I get 1 plus 1.5 and 5 minus 1.5, so I get 2.5 and 3.5. And then if we just get rid of all the lengths and look at the areas now, I have got 1.5 and 2.5 on the left-hand side. Now, if I add those together, they are going to give me, like they should give me, an area of 6. And then if I look at the areas on the right-hand side and I add those up, I will get the area of the yellow region, which is going to be 7 units squared, whatever those units are. Now, that's a pretty cool answer, I think, for something which initially I looked at, I thought, I'm not sure how you're going to be able to do this, especially with the way that top triangle is, because you don't know exactly where that is in terms of how far left of the center that is, the apex of it. So that's a pretty cool answer, I think, especially because, you know, it's a whole number. And it's, I think, not too bad. Pretty straightforward once you get stuck into it and start labeling things and you start working through it. If you were able to solve this problem and you use the same solution, or yet even better, a different solution, let me know down in the comments below. I always enjoy reading your comments, as I'm sure other people do as well. And all that is left to say is thank you so much for watching. If you enjoyed this video, please drop a like on the video. And if you're not already, please consider subscribing to the channel. Thank you so much for watching, and I'll see you next Monday at 5 PM for another problem solving video. Until then, Bye bye.